This video is for Math 95 on solution by factoring. And the idea here is that we're going to take a quadratic equation and factor it into two pieces. Well, first we're going to take a quadratic equation set equal to 0, factor it into two pieces, and then find a solution. And the whole basis for this is that when you have two numbers in our standard number system being multiplied together equaling 0, then A has to be 0, or B has to be 0, or both. In the problems that we're doing, it won't be possible for them both to be 0. Most problems anyway. But that's the general idea. The only way to multiply and get an answer of 0 is if one of these numbers is 0. There's no other way in our number system to get an answer of 0. So, to apply that to the quadratic equations, let's say we have problem 2. We've got a squared plus 5a minus 6 equals 0. So the first thing is make sure that your equation is in standard form, okay? And that means everything pushed over to one side and set equal to 0. Now to factor this, be careful because 2 times 3 is 6 and 2 and 3 add up to be 5. We're looking for something to subtract and give us 5, and that's 6 and 1, okay? So this is going to be a plus 6 times a minus 1. So now we've got these two numbers, right? Each number is what's inside the parentheses. Let's say a equals 3. Then you would have 3 plus 6 is 9, 3 minus 1 is 2, 9 times 2 is 18. So 3 is not a solution. But what if a was 1? Then you'd have 1 plus 6 is 7, 1 minus 1 is 0. So 1 is a solution. 0 times 7 would give you 0. The way we can solve this without guessing is to say, well, what value for a would make this be 0? Negative 6. Over here, what value for a would make this be 0? A equals 1. So there's two possible solutions to this, and you can plug them in and check it out. See if you've got negative 6 squared, 5 times negative 6. What does that equal? 36 minus 30 minus 6. Yep, that's 0. What about 1? 1 squared, 5 times 1 minus 6. That's 1 plus 5 minus 6. Yeah, that's 0. Okay? You don't have to check them out, but what I'm saying is that you can check them out. All right? That's the whole idea, is that these should be the numbers that when you plug them back in here, give you an answer of 0. All right, let's look at some more challenging problems. Let's see here. Problem 4. Here the factoring is a little bit tricky. Okay, so here we have to factor this. We want to get a difference of 1 in the middle. We'll split up the 3 into 3 times 1. And let's see here. Yeah, if we put the 4 here and the 1 here, then you'll have 4 minus 3 is 1, and we want the 4 negative, and we want that 3 to be positive. Okay, so there's the factorization. And it's important to check and make sure that your factorization is correct, otherwise your answer won't be correct. So now we set this up. Either k plus 1 could be 0, so k would be negative 1, or 3k minus 4 would be 0, so 3k equals 4, and k would be 4/3. So there's our two solutions for problem 4. And a lot of these quadratic equations will have two solutions. So you've got as many potential answers as the highest power of the variable. So in this case, we can have up to 2 answers. All right, let's see. Now, number 6 is where it starts to get more interesting. Here we've got n minus 7 times n plus 5 equal to negative 20. Now, a mistake that people sometimes make is to just say, oh, well, n should be 7 and n should be negative 5. This is not standard form. You don't have a 0 here, okay? So you can't draw those conclusions. What we have to do is get this one into standard form the way that this one is, set equal to 0. So to do that, we're going to have to multiply this out. N squared, you get the plus 5n minus 7n, so it's minus 2n minus 35 equals negative 20. Now I'll add that 20 over here. So now here's our 0. N squared minus 2n minus 15. And this one is pretty straightforward to factor. This should be n minus 5 times n plus 3. So if n plus 3 is 0, then n equals negative 3. If n minus 5 is 0, then n equals positive 5. Okay. So that's the process for these, is simplify what needs to be simplified, move everything to one side of the equation, and then look to what's look to factor what's there. All right, let's see here. Let's look at problem 10. We've got a plus 2 squared equals 9a. Okay, so squared means to multiply something by itself. Okay, so this will be a squared plus 4a plus 4 equals 9a. Now let's push everything over to one side. Move this over here. A squared minus 5a plus 4. And now we can factor this. A minus 4 times a minus 1. And so that says a minus 1 equals 0, so a could be 1. A minus 4 equals 0, so a could be 4. Okay, let's see here. Well, let's look at problem 16. This one's a little bit more involved. Here we've got 8 times x plus 2 plus 8 times x minus 2 equals 3 times x squared minus 4. All right, so we just need to distribute all of these. So this will be 8x plus 16 plus 8x minus 16 equals 3x squared minus 12. So these cancel out, and we end up with 16x equals 3x squared minus 12. So I'll move that 16x over here. And it's a lot easier, at least for me, to factor if this is a positive number, if this is a positive coefficient. Okay? There's nothing wrong with bringing the 3x squared and the minus 12 over to this side. I just find it easier to factor when this number is positive. Okay. So let's go ahead and do that. The 3 has got to be 3 times 1. Now I've got to try to fit the factors of 12 in here to get a difference of 16. So my choices are 1 times 12, 2 times 6, and 3 times 4. Let's see. Now normally I would pick this one to start with. I think I can tell before even putting them in there that that's not going to work. But I'll go ahead and put them in and talk about it. So let's say we put the 3 here and the 4 here. That's 12 minus 3 is 9. And if we switch these up, then it's 9 minus 4 is 5. So neither one of those works. Okay? So now with the 2 and the 6, see if I put the 6 here and the 2 here, then I get 18 minus 2 is 16. Okay, so that's what we want. We want the 18 negative, so there's the 18 being negative, and we want the 2 positive. Okay, so there's our factorization. X minus 6 is 0, so x could be 6. 3x plus 2 equals 0. So x would be negative 2/3. Okay. Try to make sure everybody can read my handwriting now. All right. So let's see what else we've got here. Okay, problems 20 and 22 are kind of similar, so let's take a look at those. 20 says y plus 3 times y plus 6 equals 3y plus 1 times y minus 4. So again, we don't have standard form. We're going to have to multiply this all out and then push everything to one side and factor. So over here, we'll get y squared, 6y and 3y make 9y plus 18. Okay, over here, 3y squared, let's see, minus 12 and plus 1, so that's minus 11y minus 4. So I'm going to push all of these over to here. I'm going to subtract y squared, subtract 9y, and subtract 18. So that'll be 0. That'll be 2y squared. I believe that'll be 20y minus 22. And you can factor it like that if you want to, but there's a common factor of 2 here, and this will make it a little bit easier to work with. And so this will be y minus 11 times y plus 2. You can factor it the way that it is here, and it won't be wrong. You'll still get the right answers, okay? I just think that it's helpful to pull that 2 out. Makes it a little bit easier to factor. So y plus 2 equals 0, so y could be negative 2. Y minus 11 equals 0, so y could equal 11. Okay. Let's see here. We'll look at one more. Problem 22. And this starts out in a very similar way. We've got 2x minus 3 times x minus 5 equals x plus 1 times x minus 3. All right, so same way we started over there. Let's multiply 2x squared, 10, and 3. Negative 10 and negative 3 will make negative 13x plus 15. And then over here, x squared minus 2x minus 3. So I'm going to move everything over to the left-hand side. Try to keep that leading coefficient positive. So let's see what we get. That's going to be all 0. This will be 1x squared minus 11x and then plus 18. So what times what is 18? That will add up to be 11, 9 and 2, right? X minus 9 times x minus 2. And so that says x could be positive 2 or x could be positive 9. Okay. Now we'll do a follow-up assignment on this topic before we move on to something new. But this is the last topic for factoring. But like I said, we'll have one more assignment for the solution by factoring, and then we'll move on to something else. And as always, if you have any questions, please let me know. Thank you.